Let's start 7.2, graphing rational functions. In this section right here, we're going to learn about a new type of function, um, rational functions you know of. Remember, we talked about rational earlier on in the year, and you probably learned it in Algebra 1, which is about dealing with fractions. Okay, so when we're dealing with rational functions, you are looking at a fraction, and specifically, you're looking at a function with a variable in the denominator. So you're going to be seeing x in the denominator a good majority of the time. So what makes these rational functions so special is that we call them a hyperbola. So we take a look at the parent function right here, and the graph of a parent function is f of x is equal to 1 over x. And it's a hyperbola. And it consists of two symmetric branches, or two symmetric parts called branches. And these branches right here, let's go ahead and see how they kind of form. If we would take a look at the diagram, I'm going to go ahead and put these little dotted lines in. And those dotted lines are represent the x and y axis. Now, the reason why we're going to put them there is because this is the parent function, the most basic hyperbola, and you can see that the branches right here, the actual solid little lines, the curves, they're on opposite sides of the what is it? Opposite sides of the axis, and those axes right there actually happen to be the asymptotes. So we have a vertical and horizontal asymptote, and so remember with the function, the the function will get close to the asymptotes but not cross. All right, so that's once again the important thing there. It says right here, as we go ahead and read in the next part, says the domain and range of all non-zero real numbers are all non-zero real numbers. So let's talk about why. Usually when we deal with the parent function right here, I'll go ahead and we choose typically numbers -2, -1, 0, 1, and 2 work out. And so in our graph, let's go ahead and plug these numbers in. Now let's start with 0. And what am I going to plug it into? I am plugging into f of x is equal to 1 over x. So when I plug in 0, it's 1 divided by 0, and hopefully we remember that that's undefined. So we'll go ahead and put undefined right here in the table. When I plug in 1, 1 divided by 1 is 1. 1 over 2 is 1/2, or 0.5. We'll go ahead and plug in -1 in for x. We got ourselves -1. Plug in -2, we got ourselves -1/2. So we have all these points here. And so let's go ahead. We need to plot these points. So in your homework, in the graphs, I'll expect you to plot them as well. And so let's go ahead at 1, 1. There's one of our points. At 2 and 1/2. And you can see right here, just based off of that, we can go ahead and write our branch, or draw in our branch. When I start going to 0, we reach our asymptote. Okay, so then that's, we're not going to put a point there. And then let's go here to -1, -1, and then we have at -2, we're at -1/2. And so remember, these are symmetrical, so that's why you'll notice some of the numbers are the same, except one is positive and the other is negative. And there you go. We have now graphed our hyperbola, which is our rational function right here. And once again, examining our function, we have domain all real numbers except x cannot equal 0. And for our range, it's all real numbers except y cannot equal 0. All right, so make sure you put those things when they ask you in your homework. So the next part right here talks about graphing translations for simple rational functions. So y, or f of x, is equal to 1 over x is our parent function. But now we take it one step further right here, and we got y is equal to a over x minus h, and then plus k. Look at the denominator. we have that x minus h. That should be familiar because in Algebra 2 earlier in the year, and even in Algebra 1, but we talked about vertex form. Remember y is equal to, go ahead and write that down. Remember y is equal to a times x minus h quantity squared plus k. So all of this stuff looks pretty familiar. We had that x minus h. Remember, that right there is your horizontal translation. K, vertical, up and down. And so you can see, in algebra, we try to use the same variables over and over to be consistent. And so how do we graph this? Okay, if I have an equation, what do I do to graph this? Step one, x is equal to h. That's one of your asymptotes, right? This right there is your vertical. And then y is equal to k. That is your horizontal. So now we know where our function is going to go, okay? And then you plot the points from left to right of the vertical asymptote, okay? And remember, you want to figure out, well, where is the middle? And so whenever we come up with our function, you got your x, your y, and then we have our numbers. The middle number should always be h. And then you're going to add, h plus 1, h plus 2 would be the higher numbers. H minus 1, h minus 2 would be the lesser number. So you get both sides of the asymptote, and then you can be able to draw your curve or your branches for the problem. Okay, and then so step 3, draw the two branches of the hyperbola. So they pass through the plotted points and approach the asymptotes. So you do want to make sure, though, you use dotted lines to show your asymptotes. Okay, not a solid line, but your dotted line. And then you go ahead and plot your points. All right, whether you have 4 points, 5 points, 6 points, you should have at least a minimum of 4. At least then you can get your basic idea of how your hyperbola will be, how it will look. One last thing that I need to include right here that's not in your notes is, well, what happens if I have a function that looks something like this? Y is equal to ax plus b over cx plus y. Okay? We have coefficients is what happens in this function. And right here, I'm going to circle a and c. Okay? That right there is your horizontal asymptote. More specifically, y is equal to a over c. All right, so if you have a binomial for your numerator and denominator, and you have a value greater than 1 attached to that x, you're going to want to go ahead and figure out that my vertical asymptote is y is equal to a over c. All right. Now, for your vertical asymptote, we'll talk more about that when we come to it towards the end of this section. So let's take a look here at number 1. Okay, it says let's graph the function. So it's pretty basic. Right here, we always start off. Hey, I look at my denominator. Do I have an h? No, it's not shifting left or right. Do I have a k, which would be right here? No, so it's not shifting up or down. So I'll go ahead right here and then start with using numbers like 0, 1, and 2, -1, -2. Okay? And let's go ahead and plug things in and see what we come up with. All right, plugging in 0, once again, that's undefined. We plug in 1, we end up with 0.25. Plug in 2, we end up with 0.125. When x is -1, you got yourself -0.25. Plug in -2, you got -0.125. All right, so we know what our asymptotes are. Remember, h and k. H is 0, K is 0. All right, none of that stuff exists right here. So I'll go ahead, I'll start off, I'll put my dotted lines down. We'll plot our points that we have right here. So we got at 1, and we're at 0.25. At 2, we're at 0.125. At negative 1, we're at negative 0.25. And at negative 2, we're at negative 0.125. So it's getting very close to that axis. And so remember, the last step right here is we'll take the points and we'll come up with our branches. Now, you're not going to know exactly where every single point is going to be unless we choose a lot of points. But that's not really the most important thing right here. Most importantly, once again, is making sure we draw our asymptotes, and then from there we at least plot 4 points so that we can get our branches at least in the general area right here. Okay? Next up, let's take a look at number 2. So number 2 is going to be looking a little different because we have that negative 2 up in our numerator. And so usually when we have negative, that does something. Maybe a reflection of some sorts. So let's take a look right here. We've got ourselves x and y. I'll go ahead and plot, and remember, there's no h, okay? Down in our numerator, there's no k right here to the side of it. So that means it's not moving anywhere. So we got 1, 2, 0, negative 1, negative 2. You plug in 0, we end up with undefined, right? Negative 2 divided by 0 is undefined. Plug in 1, we got negative 2. Plug in 2, there's negative 1. And then we have ourselves 2 and 1. So those are our points. I'll go ahead and start once again. Let's draw the asymptotes. So I'll put a dotted line over the x and y axis. And then let's plot our points. At 1, we're at negative 2. At 2, negative 1. At 0 is undefined, so we're not going to put a point there, and it makes sense because of the asymptotes once again. And then at negative 1, we're at 2. At negative 2, 1. So here we go. Let's draw the branches out. And remember, it should be symmetric, so you try your best to make it look alike on both sides of the asymptotes, and there you go. It's not in the same section as number 1, or like our parent function. So if we were to compare it to the parent function, the branches are in different quadrants. For number 2, if you look at number 1, if you compare it to the parent function, that 0.125, it made things a little bit smaller and it closer to the asymptotes a lot sooner than it did with the parent function. All right, so we've got that now. So let's go ahead right here. Let's take a look at number 3. All right, so this time we've got a few more things going on. It's going to be a little more hard. I want to circle my denominator because my denominator, I've got a value of k. And so remember, h or x is equal to k. That's one of your, well, not, let's change that. X is equal to h. And so h is your asymptote. And how do I find that? Let's take the x minus 3, set it equal to 0. And then so x is equal to 3. All right, x is equal to h, or h is equal to 3. So that right there, I'll go ahead, I'll draw one of my asymptotes right here at 3. Now that is a vertical line. And then we go ahead and figure out what k is, and we have right there, k is equal to 5. Okay. And so I'm going to go up 5. 1, 2, 3, 4, 5. All right, and there we have it. So now let's go ahead and figure out where our points should be. So with our table, where do I start? Well, remember, with the table, I said let's start where k is. So since k is 3, I'll put that in the middle. And then we have ourselves 4, 5, and then we have 2 and 1. So I'll go ahead, we start plugging things into the equation. Let's simplify it. Let's rock and roll. Right? We plug in 3, it's going to be undefined. That makes sense. Okay? 3 minus 3 is 0. 1 divided by 0, undefined. Your calculator will say no good, give you the error. Plug in 4, we got ourselves 6. When you plug in 5, you'll end up with 5.5 or 5.5. Right, when we plug in 2, you'll end up with negative 1/2 and negative 1/2, or sorry, negative 1. And then so negative 1 plus 5 is 4. And when you plug in 1 right there, you get yourself 4.5. All right, so now that we have our points, let's go ahead and draw our branches. And so at 4 and 6, there's 1 point. At 5, we're at 5.5. So we can see that our function will look something like that. And then let's plug in at 2, we're at 4. At 1, we're at 4.5. And remember, we have these boundaries with the asymptotes, so we just need to make sure that when you draw things, it gets close to the asymptote but does not cross it once again. All right, so there you have right there with number 3. Okay. They say state the domain and range, so let's do that next. We have for our domain, if I take a look going from left to right, because my values of x, it's actually, we can go ahead and put right here that my domain is all real. So it's all real numbers except x cannot equal 3. Okay, so there's my domain. Let's take a look next at our range. The same thing with the range. I can go up and down, so that means it's all real. All real numbers except this time right here, y cannot equal 5. And there's our domain and range. All right. Pretty good, right? Pretty easy, as long as you can figure out, well, what's your x and y supposed to be, or h and k, and then it's pretty much straightforward from the equation. All right, so let's go ahead and drop down to number 5, because now let's take it another step further right here. All right, so it says this time we've got to rewrite the function in terms of a over x minus h plus k. All right, if I take a look at the function, it's not in that format. So in order for us to do that, it's pretty easy. We're going to go ahead and practice and use our long division skills. So I'm going to go ahead right here. I've got x minus 5, and we're going to divide that by x plus 2. And so let's figure out how many times can x go into x. It goes into it 1 time, so I'll put 1 right there. And then we multiply things out. 1 times x, 1 times negative 5. So pretty much that right there. Remember, we subtract when we divide, right? When we use long division. So x minus x is 0. 2 minus negative 5, that becomes positive 7. So now we've got a few numbers right here. They're all very important, okay? This remainder, okay, that right there is going to represent a, your numerator. The 1, that right here is important, and this right here will represent k. Okay, so then what about my denominator? Well, that's easy. It's a no-brainer, because that your denominator is not going to change. So right here, let's go ahead and I'll write this as f of x is equal to We said your numerator is your remainder. It's going to be 7 over x minus 5. That will stay the same. And then I'm going to go ahead and put plus 1 because that was my numerator, or the number that I divided into. And so now we have our equation for our hyperbola in a different format. All right, so lastly, let's go ahead and put things together. If we were to graph this out, things will be shifting. Okay, it shifts. Let's see. If I were to do this, I'd probably want to make sure that my parabola, my axis is over here. So h is equal to 5. K right here is equal to 1. So let's go ahead. 1, 2, 3, 4, 5. Go ahead and plot those points. 1 up here. And there you go. In my chart or my table, in the middle, I'm going to go ahead and put in 5 right there. And when you plug in 5, you got yourself undefined. And then we plug in other numbers. When you plug in 6 in for x, you end up with 8. When you plug in 7, we got 4.5. Then we have -6 and -2.5. All right, so those are our points. We'll go ahead and plot those and plug them in. Let's see. Probably should have put it up higher, but it's okay. 1, 2, 3, 4, 5, 6, 7, 8. Somewhere up there. At 7, we're at 4.5. So there's our function looking something like that. And then at 3, there's -2.5, and then at 4, we're at -6. All right, so there's kind of our poor representation of that function, but there it is. All right, let's just go ahead and just try one more time right here with number 6. All right, and instead of graphing it, we're just going to go ahead and change the function into the correct format that we want. So now, to start off with, once again, we got long division. We got 3x minus 12. We'll divide that by 2x plus 8. All right, so we have that right there. Let's go ahead and plug things in. Well, how many times can 3 go into 2, though? That's going to be a little tricky one, right? What can I take 3 and multiply it by so that it equals 2? Well, how about I show you right here? What if I take 3 and multiply that by 2/3? Let's take a look what happens. The 3's cancel out, right? And so what I'm going to go ahead and put up here is 2/3. Because then 3 times 2/3 is going to be 2. We got 2x. And then 2/3 times 12, or -12. And go ahead right there. That gets us -8. So I'm going to go ahead and put -8. And remember, we are subtracting. And so 8 minus -8, that becomes 16. So remember, we have some significant things here as far as our numbers and what they represent. Remember, the 16 right there will represent your numerator, or your a value of a. Your 2/3 right here represents k. So now, the final part, or at least for what I want for all intents and purposes of what we're doing, look, y is going to be equal to, or we put f of x, it's going to be equal to our numerator, we put 16. My denominator, now that doesn't look like x minus h, right? That if I put 3x minus 12, that doesn't look like x minus h. But what can I do right here? I could factor out a 3 and I get x minus 4. That looks a lot like x minus h right there. So I want to go ahead and factor out the 3, and we have x minus 4. And then finally, for the last part, we got ourselves plus 2/3. So we have our asymptotes. My vertical asymptote is 4. My horizontal asymptote is at 2/3. All right, so now we now know how to take an equation where we have coefficients in both numerator and denominator and turn it into this y is equal to a over x minus h plus k. All right, that leads us to the end right here of 7.2. If you have any questions, once again, come by during tutorial, shoot me an email, send me a message. All right, there you go with section 7.2.